So now we'll do this relation between u, v and f. What is u now? Object distance. All the distance have to be calculated from pole. So from pole to this is the ray of light which is entering, which is incident on the mirror. So the distance between this pole and A will be called object distance, and image distance will be this is a light which is coming back, which is going back to the surface again, to the medium again. So from pole to this distance is called the image distance. Achha, let's do one more figure for how to understand this image distance and object distance for this. So many image formation we have seen. So let's draw one figure for it. Like first of all, this is F and this is C. It has to be double. It has to be double. Now we are choosing one object is beyond C. We are taking two rays, at least two rays we have to take. One is parallel to the principal axis, which after reflection it will go through the focus, and another one we have taken which will pass through the focus first and then after reflection it will be parallel. Okay, these two rays are going, and see there where they are meeting at a point. They are meeting at a point, and on that point if we draw one, as because they are meeting at this point, we are drawing the image over here. So we are getting one image of this object which is beyond C, and now we are getting the image in between C and F. So now this is the pole. The distance between this pole and the object is called the U. U means the object distance. And the next one, the distance between pole and image is called the V, image distance. Okay, and the distance between pole and F is the focal length. This figure I have drawn for the understanding only for the object distance and the image distance. Now let's back to the same figure. Giving a point A, and this is I, and the normal here. Now from the laws of reflection, this is I and this is R, which will be equal. We are not taking it I and R here, we are taking it as theta, okay, theta. So now next, give the name B. Now angle ABC equal to angle CBI, which is actually theta, from the laws of reflection. Now we are taking three more angles. First one is alpha, next one beta, and next one gamma. These three angles we are choosing. And one more thing we are doing here, one perpendicular we are drawing on the principal axis from the B point. Now we can say that the sine alpha equal to this BM by AM. Now sine beta equal to again BM by CM. Now sine gamma equal to Bm by Im. Okay. One more thing, we are getting it here. Two triangles. One triangle is ABC. ABC is a triangle. For ABC we can write that beta equal to alpha plus theta. Correct? Beta equal to alpha plus theta. Beta is this one and this is the external angle, and these two are the sum of the opposite internal angles. Now the next triangle ABI. There also gamma equal to alpha plus 2 theta. From there, here we are theta का value put करते हैं. So we will be getting it here theta equal to beta minus alpha, and here it will be alpha plus 2 beta minus 2 alpha. So 2 beta minus alpha. So now 2 beta will be gamma plus alpha. Okay, this much we got. Now again the same consideration is coming, that is for the paraxial rays. For the paraxial rays, these B and P are very close to each other, for paraxial rays. B and P very close to each other. So this value of this alpha, beta and gamma is very small. Alpha, beta and gamma is very small. So alpha can be taken as फिर से एक बार लिखते हैं. Just see now, this as we have chosen B and P are very close, so here this M will be overlapping with this IP, means we are not considering this BM, we will consider now BP. So BP by AP, and the next beta will be BP by AP. BP by AP? No. BP by AP? No. BP by CP. And the next one, gamma, will be equal to BP by IP. BP by IP. The previous relation we got, that is 2 beta equal to gamma plus alpha. So here you understand that why this BP and AP is coming, because there's a B and P are very close to each other, so that's why this perpendicular becomes very close to this overlapping with this BP. So we are considering this BM as BP. Now putting the values here, it is 2 BP by CP equal to gamma is BP by IP, and BP by AP. So now 2 by CP equal to 1 by IP plus 1 by AP. Now we can write that AP is actually U, IP is actually V. So 1 by V plus 1 by U equal to 2 by Cp. Cp is actually R. 2 by R. So 1 by U plus 1 by V equal to 1 by F. Why 2 by R equal to 1 by F? Because we got the relation, that is our radius of curvature is just half of radius of curvature is just double of F. So this relation we got. This is actually the Miller formula, where U is the object distance, V is the image distance, and F is the focal length. Now there is the most important thing, that is sign convention. Sign convention now we have taken. We got two formulas now. One is this one, and another one is the R equal to half F. Next, sign convention, which is very important for doing all kind of numericals and magnification also. Sign convention. For the convex or the concave, for the both the cases, we have to remember 2 points. First of all, the light ray always comes from the left side of the page or the board or anywhere. Light always falls on the mirror from the left side, from the left to right. It will go from left to right. And the second point, what is that? Now all the distances has to be calculated from pole. This is the pole. From pole, whether it is convex or concave one, all the distance have to be calculated from pole. So now, what is this sign convention? Now first of all, it will work for the distance also and the size also, size of the object and image. First, we are talking about the size of both object and image. So now for the size, as we know, the object will always be above the principal axis. So whichever is above the principal axis, that will be taken as positive. So object size is always positive. Okay. Now for the image one, इमेज मतलब तो दो काइंड ऑफ इमेज आ रहा है, रियल एंड वर्चुअल. रियल क्या होता है? रियल इन्वर्टेड होता है, वो तो अबव द प्रिंसिपल एक्सिस नहीं है, वो तो नीचे आएगा, ऐसे आएगा. तो द इमेज साइज फॉर रियल it will be negative. All the things above principal axis positive, all the things below principal axis negative. नीचे जा रहे हैं. और फॉर द वर्चुअल इमेज साइज, फॉर वर्चुअल तो इन्वर्टेड नहीं होता है, वर्चुअल इरेक्ट होता है, मतलब ऐसे मिलेगा, बिहाइंड द मिरर मिलेगा. सो दैट फॉर दैट वर्चुअल इमेज इट विल बी पॉजिटिव. दिस इज फॉर द साइज वन. साइज नॉट द डिस्टेंस. Size one means how much it is. Okay, like for the concave mirror one, when the object is between pole and F, it will form a virtual image. In that case, it will of course will get the virtual image, and the object size will be positive, image size will also be positive. Now the next, distance means we know about three force. We are talking about this U, V, F and R. These forces are there. U, which is always whether it is convex or concave, which will be always in front of the mirror. So as because the distance is calculated from pole, this side, from pole Just now I told that light, we are considering the light is traveling from left side to the right side of the pitch. But the distance is calculated from pole, like in the opposite direction of the light, in the opposite direction of light. So it will be negative. That means the light, if the light is falling from the left to right, but the distance is calculated from the opposite direction, then it will be negative. U negative. Now for concave, if, as because if is in front of the mirror, f will be negative. And for the convex, as it is behind the mirror, so it will be positive. Why positive? Because see, it is going to the direction of light. From the pole to this up to this much is the f. Up to this much is the f. So the distance is calculated in the direction of light. So this will be positive. Convex one is positive. Okay. Focal length done. Next one, R. R is also for the concave one negative and for the convex one positive. क्या रहेगा? V रहेगा. V का बहुत सारे cases है. Like for the virtual one, which will form behind the mirror, will of course positive. V for virtual. Positive. And for real, negative. Q negative क्योंकि the image will form in front of the mirror. So the distance will calculate it from the pole again in the opposite direction, so it will be negative. Okay. So these are the sign convention, which is always very much important for the numericals. We will do for the mirror one. And next comes the magnification part. Magnification is about the sizes. मैग्निफिकेशन तो वर्ड में ही आ रहा है कि हाउ मच मैग्नीफाई इट इज. सो इट इज एक्चुअली रेशियो ऑफ द इमेज साइज बाय ऑब्जेक्ट साइज. अगर ऑब्जेक्ट से इमेज बड़ा हुआ तो मैग्निफिकेशन ग्रेटर देन 1, सेम हुआ तो इक्वल टू 1, छोटा हुआ तो लेस देन 1. Like for the concave one, for concave virtual, magnification always greater than 1. And for concave, when at C point, object is at C, image is at C also, then magnification is 1, means same size. Also for the plane mirror also magnification is 1. Now less than 1 is for concave one when it is forming real image. But only two cases, when the object is at infinity and when the object is beyond C. In that case, concave real for some cases. And for the convex one, it will form a virtual image, but the image size will be smaller than the object, so it will not be greater than 1. Okay, thank you.